All right, so I mean, you know the basics, right? I mean, match,
Right.
user, there's some of this random stuff. So then you always return something if you're doing a match. Your user can take like filters. So do you need to leave? What time do you need to leave?
Oh, no.
Oh, okay. You can do like filters like this. So if it's like an exact match, and then like filter and like what I want, right? You can also do like where clauses. So you can pretty much do the same query and do user where u.email equals.
Yeah, I found that where seems to be more necessary when you're matching when you're matching two types of nodes.
Yep.
I think.
Well, possibly. So I guess it depends on like if you know like. Yeah, it kind of depends on the use case, I guess. So yeah, so the difference is that. So the way I understand it with Neo4j is if I do it like this, that internally Neo4j uses like an R tree to figure out like what basically figure out the matches here. So it doesn't take like the whole subset of users. Like it'll actually break down to get to a more efficient result.
Okay.
Whereas using the where clause, it'll like pull in all the users into memory and then sort through them with the where clause. So I think it's a little less efficient.
Sure.
But yeah, so it becomes necessary. So like if I want to do like, I think this is a syntax. Like I can do reg x.
So you can't do something like that in the.
No, you can't.
Okay.
Okay, so yeah, so like you can do regular expressions. In there with a where clause, but yeah, you can. I mean, there'd be no way to like really indicate that syntax. I mean, I guess like with like MongoDB or something, you can, but because they have this kind of like weird whole like JSON object notation, like greater than. But yeah, so like where clause would be for that. But you could. Let's see, what's this guy like? So you could do. Company. Yeah, so I mean, you can do like matches across like multiple things. Is that what you're meaning?
No, but actually that's a question I do have with the relationships, the formatting of the arrows.
Yeah.
Why is this one pointing this way when?
So it's how you define your relationship, right? I mean, so like when you create the relationship, you can determine which way that arrow actually goes.
Okay.
But so let's say like let's see, so create. Yeah, so like you kind of here it'd just be like you're creating a relationship.
Right.
That kind of makes some like logical sense. So like the computer sits on the table, right? So when that kind of becomes important or can be important is like when doing doing queries. So then let's say that. Okay, so I've created a sticker. Oh yeah. Sorry. So like here, I mean, you need to do a match first. Right. Just release that.
Bring that too.
Yeah. So now I have a sticker.
Right.
That sits on. So a sticker that sits on a table. So a sticker that sits on a computer that sits on a table, right? So now let's say that you wanted to match like all the relationships like from the sticker, like all the nodes that like this may follow in a path. So then you could do things like and then so then this could be like any node, right? So then by default, it's just going to return the very next thing in the lineage. But you can do something like, now I want like everything. So now it's going to be the computer and the table. So it'll take like whatever that relationship is, with this asterisk, and I'll say like how many ever hops it takes to get there. So you can also, I can't remember the format. I don't know if it's like 1, 2, that could be.
Oh, that's the depth or whatever?
Yeah.
Okay.
What the syntax is, but yeah, you can tell like how many hops you want to do, like all hops. So all hops can be a little tricky because like if you end up having like a continuous like loop, like throughout like your whole like graph tree, then like you might end up with like millions of like results returned.
Right.
Oh, it is astral surface, so it's just so pretty much the same thing. You can also do like 2 second hops. What's that do? Yeah.
Okay.
So you can also say like, okay, like skip the first hop and then give me the next one.
Would there be a way similarly where the sticker and the computer both sits on relationships to the next?
Right.
If that relationship was different, would there be a way to, in a similar fashion, get
so
pretty much anything that the sticker could be related to?
Yeah. So tree printed on. Okay, so tree is printed on the sticker, which is printed on. I think I just created some extra ones here.
Oh, that makes sense.
Yeah, so I'm not matching any particular one, so I'm just saying like it's always this, right? So, so computers, that should be right. And that was, I think this was the first one maybe that I did. Or I created an extra one somewhere. So then I could do, so you have the tree is printed on the sticker, which sits on the computer. Didn't the computer sit on the table? Oh, it's this one. Okay. Gotcha. So this sits on the table. So the tree is printed on the fingers. Okay, so then you could do match tree. And you could just do that. Okay. Return that. So that'll basically go over any relationship. to whatever node like you want. So you could do, let's say, like if you knew like you were trying to get the computer, you know, you could do let's see, what would it be? 1, 2. Let's see which one. Yeah. So if you're trying to get the computer from the tree, you know, you could just do that, and it doesn't really matter what that relationship is. Like you're just, but the direction does matter, right?
Okay.
So if you did, let's say if we took that same scenario, let's see what this is. So if we did, let's see, that's from the tree. So 2 over, so a sticker. So manufacturer. Okay, so now we have kind of some different relationships here, where so from the tree, let's see, so from the tree, you know, it's printed on, and so like we ran our original query. Let's see. So here, so it'd be like, so the tree, and we're going over 2 hops, so really we're trying to get to the computer. But, so even though we don't care about the relationship, the direction here matters, yeah, because so it won't pull in, the manufacturer.
But could you though, by not using the arrow, by just doing the hyphen?
Yeah. So then it'll pull in the manufacturer as well.
All right.
Yeah. So that's kind of like where direction actually matters, or it doesn't matter, yeah, depending on what you're actually trying to pull.
Well, it gives you some control.
Yeah.
Whether or not you decide to use it.
Right.
Okay.
And so you could, it's a sticker. Yes, so that's kind of that. I feel like I've only used hops like a few times. Like it's probably more valuable when doing like statistical stuff.
I would think so.
Yeah, generally like you kind of know what you want. Like it's usually like one level in or something. But one of the like for me, like one of the things that I always had to wrap my head around is the fact that like Neo4j returns, like somehow in my mind I'm always trying to think about like, well, like how does it return this result set? But really like it returned like because I'm always like, okay, like if it returns my computer, like how does it know like what sticker goes with that, you know? And so that's kind of where we always have that triangle relationship between the company, the user, and the item, whatever it is. So then like a user could be part of another company, you know, and have a different item. And so Neo4j always returns a Cartesian value. So basically these result sets that match up together. So like it basically returns like, you know, so like if I return like match. So if I just return everything, right? So like it will return, if you look at this, like it basically returns just kind of this nodes of like all these separate nodes.
Yeah.
And then, you know, it just returns all these nodes back. And the actual relationship happens like in the actual driver. So in our case, the JavaScript driver, that then looks at those and says like, okay, like what is my like relationship here? So so Neo4j actually just returns like this list of Cartesian values to us, and then we have to kind of figure out what those actual relationships are. What's something else? So you know, like you can also like chain stuff like for so I don't know what my tree example was. So the stickers. sticker. And then, so like you could just continue like chaining this query,
Right.
but it's really still kind of broken up into segments. Like it, so this has kind of confused me with like merges, because I assume that like okay, like this basically the idea that this whole thing doesn't exist, but it doesn't really seem to work that way. Like it actually still kind of breaks up like the individual relationships.
Yeah, because I mean the idea, right, is that this statement assumes this already exists.
Correct. Right. Yeah.
And you're only going to try to merge the tree, right?
Yeah.
Okay.
Well, actually, not quite. So merge, like, so merge has to match exactly,
Okay.
or it will create the relationship. So in this case, so generally with merge, you always want to do your matches first.
Sure.
So you might do something like this. And then actually use the node, like the node reference value here.
Yeah.
Because if you try to do like the merge statement, like if for some reason like that whole thing doesn't match exactly, like it'll recreate all of the nodes. So even if like this, you know, like you had UUID something,
Yeah.
but this part didn't. So even if this matches, the tree portion matches, but this doesn't match, it will recreate the tree with the UUID of this and then print it on S. So it's basically like an all or nothing type of thing. And that really confused me at first. I was like, why do I have all these like orphan nodes? You know, like where are they coming from?
I came across that.
Yeah. Okay.
So that makes sense. But yeah, I did figure out like, yeah, you want to do your matching and then do your merge. Okay.
Yeah, so that's always one thing that always kind of tripped me up a little bit in there. Yeah, so merge is all or nothing. So generally I'll do my matches first and then just use the the node that's in here. That's one thing. Something else. So something else also is optional match, and this I kind of hate the way that Cypher does this, like the Neo4j. So a match. Let's see. So this statement will. So this whole statement will return nothing. So even though we have stickers, and so it's actually kind of a cool thing with the queries is that like if any part of your query fails, or like of your matches, okay, well there's kind of a caveat with that. So when you're doing your matches, if one of your matches, like say at the top of your query, fails, then the whole query will fail and it won't continue. Now that's not true if I do create. So this should give me yep, okay. So with so yeah, in between like creates and matches, like you have to basically do this with. And so with is basically saying what do you want to use from the prior portion in the rest of the query. So you can do the asterisks and say like I want to use everything, or I could just say like I just want from this point on I only want the L or lollipop to be available to me. And so basically just kind of like reducing what you're using in your result set. But in this case I'll just use all. So this will still create a lollipop, even though this fails. So my lollipop is created, but it didn't return any results to me. So it doesn't return any results to me, but it still created the lollipop. So a lot of times what I'll try to do is do So a lot of times, so I'll try and do all of my matches at the very beginning, and then do like my creates. And so in this case, dummies won't be created because popsicle fails.
Right.
So nothing changed. But versus earlier when I did it, like with the with statement, it's almost like a subquery. So the first query actually gets executed, and then the next one fails. But the create has already happened, so it's a done deal. So that's a caveat that I always kind of found difficult. What else? What's another one? That kind of makes sense a little bit?
It does, yeah.
You can do things like so you can like change this stuff up. Do something like this. So using with, you could basically like kind of transform the information that you want to use for the rest of the query. So I'm basically saying match a user, and then I'm creating this object basically, and I'm reassigning. So I'm saying I'm creating an object with username as u.name, so user.name, and then I'm saying I want this object to be referenced as new user in the rest of the query.
Yeah.
This actually. That's fine. So then I'm going to create a node called new user, and now I'm referencing it as NU. So then set NU to equal new user. So this. How do I create two of them? That's right. Oh, yeah, there's probably two users in here. Yeah, that'd be right.
Okay. So it's
a new user, so now it has username, user 0, username, user 1.
Okay.
So, does that make sense?
Yeah.
Kind of, yeah. So with is pretty handy with like kind of like transforming data. There's one thing that there's a couple places in the code where I clone nodes. So with u as test. Create.
So you're copying the whole.
Yeah.
The word.
Yeah. Right. Now, right now I don't have any constraints.
Would you set OU to test or you?
Oh yeah, sorry. You're right. So right now, I don't have any. I'm gonna do something like. I don't have any constraints on the database, but at some point we're probably going to do a constraint for the UUID. So just in case it ever issues, there is the possibility that the UUID4 does issue a collision to where two UUIDs are the same. So right now I assume that they're always going to be unique, but we should do a constraint on them now. One of the things that I've seen with Neo4j, I think at this point where I set this, it's a live set. So we would actually get a conflict here because we would now have two of the same UUIDs in the database at the same time. So I need to figure out how we actually handle that. I haven't tried it or tested it, but anyway, so that's kind of something. That's a set return. Create. so now I just reset UUID as something else, so it should be fun. Okay, cool. That's another thing. Let's see, I did optional matches, right? Did I do optional match?
I don't think you actually showed it.
Oh, okay. So let's say that. Oh yeah. Let's see, so this was an example of. Like, so it's not going to return anything because the popsicle fails. So I can do an optional match, and so it won't fail if it doesn't match. It just won't be there, and it'll return null. So it did null 3 times because there's 3 stickers, and so it's basically returning a null value for each one of those matches on there.
That's it.
So that gets a little weird, like if if you're trying to do stuff like I don't know what a good example is. So let's say like so we do that, but then we want to say that gummies. I don't know. So create, so gummies makes popsicles, right? That's gonna fail because it's gonna, I'm trying to reference this P, but it's a null value, so there's no way that it can actually like reference it. So this is always kind of a weird one in that you have to do is like. So for each case when it's not P, so for each item, so case when P is not else. Okay, so this is kind of their weird, like, for each syntax.
Mm-hmm.
So basically, item in whatever like that array value is. So now I'm saying, so if P is not, let's see, mismatched. So when P is not null, then return P as like an array. Otherwise, just return an empty array so it doesn't do the for each loop. So then there's this pipe. And then we can do something with that pipe. Create G and P. And I think that will work. Okay, so it created my gummies, but it didn't create popsicle. So now let's say that let's see, what does it match? Let's see, optional match popsicle. Let's actually do sticker. Okay. So let's do match sticker. So let's So here's another example of using with. So I do match sticker, right, which is going to pull in a whole Cartesian value of like all the stickers. But then I say like, okay, like I just want to use one sticker, so I'm going to do with s limit 1, and then I want to create that the sticker likes that popsicle or likes popsicle that I'm creating. Okay, so now if I do it, this should create that the gummies likes that dude. So there it is right there. So if we look back at our query, so it found one popsicle. Let's see, So it found one popsicle, and then it said that the gummies, yeah. So it created the gummies, and when it found this particular match that the sticker likes a popsicle, then it created the gummies makes popsicle. Easy.
I get it.
Yeah, right. Yeah, right. Some of the stuff starts becoming like super complicated, like real fast, like with the relationships. It's like, okay, like how do I do this? You know, right?
Yeah.
So one of the things that I hate about like the for each loop is that you can't, like, let's say you create a new variable in here, like, or a new relationship, popsicle. So let's say I make this relationship here or this new node. Like there's no way for me to actually like use this A outside of this for each loop. So I couldn't do return A here. So like it'll be not defined. So I would have to basically like do
another match. So.
Yeah, like do a match to pull the values back out. But then I think one of the issues that I ran into before is because like all these values are still here, like it will kind of like duplicate the values in your return result. So sometimes like if I'm doing these for each, I would just like completely escape that and then redo my like query. Again as a completely separate query. So that's I wish this would change. I mean, it kind of makes sense in that like you don't really like there'd be no way for the matching to really occur. I guess like on on that level. But anyways, I wish that was better. Let's see what else. So return values. So let's say we do match stickers, right? And so now we want to think about how we return results like back to the end user, like in JSON format. So you can do, so you can define your object, and then you can do things like I mean we didn't have a name, but let's say so you want to do like a name, sticker.name. And let's say there's like a button, like the sticker likes a lot of popsicles. You could do collect, and this will create an array of all the popsicles in there of the relationships. So that's what's really cool. Like I like about Neo4j is that like this could have like a bunch of relationships to popsicles, and you use collect, and it'll figure out like which ones go where, and return that. So it'll be an array of stickers with an array of the popsicles that it relates to, like inside of that.
Okay, that's cool.
Yeah. So if we look at our table, so its name is known an array of popsicles if it existed. Yeah. So so this kind of returned an empty object, which is not really cool. So then you kind of end up doing this stuff. So case when P is not null, then P else. Still missing. Case when P is you might do it with this. Does that work? Still doesn't work. I don't know. All right. Somehow you can filter out like Oh, actually, popsicle would exist here in this case. So it just doesn't have anything in it. Yeah. Okay. Yeah. So that makes sense. Okay. So that's that. What else? trying to think of some other like weird oddities that you might kind of run into. Do you have any questions like on your project that you're working on that you ran into?
No, I actually feel like I've got a pretty good hold on the data. Now I'm trying to figure out how to get. Now I'm trying to just figure out like I use DreamHost to do my hosting.
Okay.
Trying to figure out how to get Neo4j on that.
Oh yeah.
So I ended up going with their Dream Compute, which is you just get a. So I tried using the VPS, but you're kind of limited because you don't get root user access.
Yeah.
So I couldn't update Java to install Neo4j. So I ended up just getting setting up a. Where I actually just you basically just get your own virtual machine. So now I'm trying to figure out the best way to host the server using Ubuntu.
Do you ever use DigitalOcean?
Not recently.
Yeah. Okay.
So I got Docker installed. I actually got Neo4j installed, and I was like, well, instead of trying to figure out how to get this all configured properly, I just put it in Docker.
Yeah.
So that's as far as I got last night.
Gotcha. And you can install Neo4j like on the server. Like directly.
I did.
Yeah.
And then I was thinking about it again, like, well, if I got it installed on the server, that should be fine. Because
Yeah.
I'm only going to be doing, it's not like it's going to be multiple projects on the same server.
Yeah.
So then I was thinking, like, well, Docker is probably unnecessary.
Yeah. And,
So I guess I'm just trying to figure out the logistics of how it's all going to work.
Yeah. Yeah, I mean, Docker is good for like the scalability. Like when you figure out Docker, like it is kind of nice, especially if you're okay like putting your code out publicly. I feel like Docker is a nuisance when you're like trying to protect your code. Because you can push it to Docker Hub and then pull it right from your server. Or pull it from Docker to.
Yeah, because let's see, what was I going to show you? Oh, because eventually the server's going to have to just run basically in a loop. Where did it go? Where? There it is. So eventually the server will. Oh, not connected.
Stop this.